Hello students, I'm happy to get back to you through the next video. Welcome to the physics class. So we have been discussing about the fifth chapter in volume 1, Electromagnetic Waves, in the previous video, in which we learnt about the applications of electromagnetic waves, the definitions, the experimental proof of Maxwell's theory, that is the Hertz experiment, and then we learnt about the properties of electromagnetic wave and the sources of electromagnetic wave. And here in this session, we will be learning about the electromagnetic spectrum. And in the next video, we will be discussing the important part of the chapter, the mathematical derivations. So here in this session, or for the next few minutes, we will be discussing about electromagnetic spectrum. What is an electromagnetic spectrum? So before we could get into the chapter, I would like to start with a question. We are all very familiar with the word visible light. What is visible light? The light that we can see and the light that helps us to see things. And you are also quite familiar with the word called spectrum. What is the spectrum of white light? That is nothing but the rainbow. The white light splits into its components and we are able to see the 7 colors. You will be doing it in your 12th standard and you will be seeing this spectrum with the help of a white light and a grating. Well, this is what we call it as a white light spectrum or spectrum of a white light, and we know there is something called visible light. Are there light that are invisible? Can a light be invisible? Well, when you say electromagnet, light is a wave and light has a spectrum. Electromagnetic wave also has a spectrum. As you can see here in this, 7 colors combine together to form a white light. Similarly, there are certain components who combine together, or together we call them as an electromagnetic spectrum. So this electromagnetic spectrum has members who are invisible to our eyes. One member of this electromagnetic spectrum is our visible light. So there are people who are invisible to our eyes. Okay, what is electromagnetic spectrum? Electromagnetic spectrum is an orderly distribution of electromagnetic waves in terms of wavelength or frequency. Well, when I say wavelength, you know, a wave is a crust and a trough. A positive cycle and a negative cycle together we call as a wave. A length of one wave is what you call it as a wavelength. Frequency is the number of waves in a unit time is what we call it as a frequency. So this electromagnetic spectrum is arranging the waves according to their wavelength in the increasing order or in the decreasing order of wavelength or frequency. So who are the members of this electromagnetic spectrum? As you can see below, ultraviolet ray, UV ray, gamma ray, X-rays, microwaves, radio waves, they all come inside. One member of this family is our visible light. You're all very familiar with joint family. Joint family is like you'll have uncles, aunties, grandparents, and your cousins, everything together. And this electromagnetic spectrum is more like a joint family. You are asked to arrange your family members according to their age. How will you put them? You'll put your grandfather, grandmother, your father, mother. Then if you have a elder sibling, you'll put that elder sibling, and then you, then your younger sibling. So this is how we arrange. So similarly here, this electromagnetic spectrum has various members in its family, and the members are arranged according to their wavelength in the decreasing order of the wavelength, or you can say in the increasing order of their frequency. That is, radio wave has the highest wavelength. Gamma ray has the lowest wavelength. So listen carefully. Radio wave has the highest wavelength, but it has the lowest frequency. Gamma ray has the highest frequency and the lowest wavelength, which means this wavelength and frequency are inversely proportional to each other. So as wavelength increases, the frequency will decrease. Well, so here in this particular thing, the electromagnetic spectrum has various radiations, and these radiations are arranged according to increase in frequency. Well, okay. Can we get electromagnetic spectrum from every object? Do we get electromagnetic spectrum from the light that I have in my house? What are the sources and how far can it travel? What are its properties? These are the things which we are going to discuss now. So before we could go deep into it, we will have a small introduction about each member of the electromagnetic spectrum. One very good source of this electromagnetic spectrum is sun. Sun gives out every single radiation from radio waves to gamma rays. Well, and do every single member of this electromagnetic spectrum come and reach us? No. Few have a higher penetrating power. They will come and reach the ground level, and certain radiation they cannot penetrate and they just vanish or they get filtered through the layers in the atmosphere. And what kind of source give out all this radiation is every body that has a certain temperature can give out radiation. The higher the temperature, the more number of radiations they can produce. For example, when a body is in a very high temperature, they can produce almost every single radiation. If it has a lower temperature, it can produce radiation based on its temperature. You can see here in the picture for 100 Kelvin, when the temperature is 100 Kelvin, it can produce radiation still IR. It can produce radio wave, it can produce microwave and infrared radiation. If you increase the temperature to 100 million Kelvin, it can produce radiation from radio to X-rays and so on. So the first member of the family is radio waves. These radio waves are produced by stars. Of course, I said sun is a good source of every single member. So every radiation comes from a star. And what are the other possible sources? The other possible sources are electronic circuits. It is produced by oscillators in electronic circuits. So the wavelength of a radio wave is from 10 to the power minus 1 to 10 to the power 4 meters. And the frequency ranges from 3 into 10 to the power 9 hertz to 3 into 10 to the power 4 hertz. This radio waves can obey reflection and diffraction. And when I say radio, we know where it is used. It is mostly used in the communication system like radio, television, and in cellular phones. And the next member is microwaves. This microwaves can also be produced by electronic circuits. And what is the wavelength? The wavelength ranges from 10 to the power minus 3 meters to 10 to the power minus 1 meter. And its frequency ranges from 3 into 10 to the power 11 hertz to 1 into 10 to the power 9 hertz. And where do we use this? It is used in radar systems for aircraft navigation. It is used to find the speed of a vehicle, and of course it is used in cooking processes like micro ovens, and is also used for very long distance wireless communications through satellites. Next is the infrared radiations, or IR rays in short. It is produced by hot bodies. Anything that is hot can give away IR rays. The wavelength ranges from 8 into 10 to the power minus 7 meter to 5 into 10 to the power minus 3 meter, and the frequency ranges from 4 into 10 to the power 14 hertz to 6 into 10 to the power 10 hertz. And this particular radiation provides electrical energy to satellites by means of solar cells. And it is also used to produce dehydrated fruits, and it is used in greenhouses, and it is also used for certain treatments like muscular sprain and pain. And it is also used in TV remotes, used for thermal imaging, used in night visions, remote controls, and so on. And the next very familiar member of the family is visible light. Visible light, there's nothing much to say. We know more about it and we've seen it. The wavelength of the visible light is 4 into 10 to the power 7 meters to 7 into 10 to the power minus 7 meter. And the frequency ranges from 7 into 10 to the power 14 hertz to 4 into 10 to the power 14 hertz. When you look into its frequency and wavelength, this is one of the smallest portion in the electromagnetic spectrum. So we are able to see only a very, very small portion of the electromagnetic spectrum. And of course, visible light obeys reflection, refraction, interference, and so on. It can be used to study structure of molecules, molecular arrangements, and of course, photography, and it helps us to see things. Next one is ultraviolet waves. It is produced by sun, ionized gases, and by arcs. Arc is when you come to the lab, you will be able to see white light and an yellow light kept in a huge rectangular box. And one, we call it as a mercury vapor lamp, and they are all good examples for giving out a UV radiation. Such lamps can give out ultraviolet radiation. The wavelength of ultraviolet radiation is 6 into 10 to the power minus 10 meters to 4 into 10 to the power minus 7 meter. And the frequency is from 5 into 10 to the power 17 hertz to 7 into 10 to the power 14 hertz. It has a very less penetrating power. It cannot travel or it cannot penetrate much. It can be absorbed by the atmospheric ozone, and it's very harmful to the human body. Since it is harmful, God designed it in such a way that it cannot penetrate much, and the atmosphere safeguards us from this particular radiation. And what are the uses? It is used to destroy bacteria, it is used in sterilization, it is used in alarms, and it is used to in forensic department. As you can see here, the ultraviolet radiation that comes from the space, they don't come to the ground surface much. Most of them are filtered even before ozone layer, and much are filtered by the ozone layer, and very, very small percentage of ultraviolet radiation happens to come and reach the ground surface. And the next is X-rays. X-rays are produced when there is a sudden deceleration of high-speed electron at high atomic number target. And it is also produced by electronic transitions among the innermost orbit of atoms. This atomic level energy gets converted to X-rays. So when I said deceleration, it is just the opposite of acceleration. The wavelength ranges from 10 to the power minus 13 meters to 10 to the power 8 meters, and the frequency from 3 into 10 to the power 21 hertz to 1 into 10 to the power 16 hertz. And you know, these X-rays have more penetrating power when compared to that of UV rays, and it is used for studying atomic electron shells, crystal structures, and it is also used in medical field. The next one is gamma rays. So what are gamma rays? It is produced by the transition of atomic nuclei and decay of certain elementary particles. And this particular gamma rays are capable of producing chemical reactions on photographic plates. Fluorescence, you know, it can make things glow. Ionization and diffraction. Where do we use this gamma rays? It is used for certain treatments like cancer. The radiation therapy that they give for cancer, it is nothing but the gamma ray. And this gamma ray has a very high penetrating power when compared to X-ray and ultraviolet radiation. Well, so far, I believe that you could have noted down whatever I said. If you have noted down the words, the numbers, which I have mentioned few minutes ago, you will be able to answer this question. I've put this quiz in the middle of the session because I know most of you are not watching this video fully and most of you are not taking notes. So this is a small test to know how many of you are listening. So here is the question. Try to answer this question and send it to me right after watching the video so that I will know how many of you are in track. What type of electromagnetic radiation has the longest wavelength? What type of electromagnetic radiation has the highest frequency? What type of electromagnetic radiation has the most energy? What color has the shortest wavelength? So what color has the shortest wavelength? I didn't mention it, but it is something that you can think related with the visible spectrum and try to give me an answer. Okay, we'll move on to the next topic, black body radiation. What is a black body? I remember teaching you about black body when we were discussing about thermodynamics in your 11th standard. Black body radiation is the radiation that is being given out of a hot body. When an object burns, it emits color. You're very much aware of it. When it emits colors, colors are nothing but a part of an electromagnetic radiation. So it is giving out some electromagnetic radiation. This color depends upon the temperature of the body. For example, when you are burning a wood or when you are using a gas stove, you might have looked into the flame. Sometimes the flame is blue, sometimes the flame is red, yellow, or white. This color indicates the temperature of the particular object. Initially, if the object becomes hot, it glows in red color. When you increase, it becomes reddish orange. And when you keep increasing, if at its hottest temperature, it will be white in color. So as you keep increasing the temperature, the color changes. So the color of the object is because of the temperature of the object. So as the temperature varies, what happens? The radiation that comes out of the body also varies. So the higher the temperature, the more the radiation is. And this is what we call it as a black body radiation. And this spectrum, we call it as a black body spectrum. And the curve depends upon the temperature of the body. Well, next, we are going to learn about the type of spectrum. There are two major types of spectrum, emission spectrum and absorption spectrum. So these two major categories. What is an emission spectrum and what is an absorption spectrum? Well, as you can see here in this image, we have a hot gas. Whenever there is a temperature or whenever there is a increase in temperature, that particular object is capable of giving out a radiation. So this is a self-luminant object, an object which can give out radiation on its own. And the radiation is being passed through a prism and it is studied. And we will get a spectrum. Whereas here, your light or your source gives out some radiation. This radiation passes through a substance and then you study it. Mostly how it will be is you will be having a clear idea of your light source. For example, here they've given a bulb. So you know what color it is, what kind of wavelength comes out of it, you know it. When you allow this light to pass through a cold gas, what happens is this cold gas will absorb certain radiations and then the rest of them will go out and you will be able to study only the rest of the radiation or the remaining part of the spectrum that goes. Okay, I'll tell the definition in simple words. When a spectrum of a self-luminous source is a source that can light up on its own, like sun. When the spectrum of a self-luminous source is taken, we get an emission spectrum. It can emit light on its own. Whereas here, in absorption spectrum, the light is allowed to pass through a medium or an absorbing substance. Then the spectrum is obtained and that is known as an absorption spectrum. and it is a characteristic of absorbing substance. The spectrum gives us the characters of the medium through which the light passes through. This emission spectrum and absorption spectrum can be divided into further three categories: line spectrum, band spectrum, and continuous spectrum. So when I say an emission spectrum is divided into three: continuous emission spectrum, line emission spectrum, and band emission spectrum. So what is a continuous emission spectrum? If the light from a lamp is allowed to pass through a prism, it splits into 7 colors. And this 7 colors, you will be able to see it in a continuous form, like that of a rainbow. The color keeps fading and the next color starts. Then one fades and the next starts. So that's how it is. So it is continuous. So you call it as a continuous spectrum. Whereas in line spectrum, suppose light from a hot gas is allowed to pass through a prism, certain lines are observed. These lines are seen to be discontinuous. You have one line and then other line, and you have a black or a dark area in between the lines. So it's not continuous, it is discontinuous. Why do we get such? Because such spectra arises due to the excited atom of elements. So with the help of this spectrum, you will be able to find the characteristics of the element that are found in the hot gas. So you will be able to find the components of the source. So what are the elements that are found? The next one is band emission spectrum. Band emission spectrum consists of bands. Here when you look into continuous, you have colors, continuous colors. Whereas in lines, it's just sharp lines. But here in bands, it's a combination of continuous and line. You have bands, or you can even call it as a thick lines, and you have dark space in between. And these are emitted by gases with more than one atom per molecule. This spectrum does not have a sharp edge on both the sides. It will have sharp edge on one side, and the other side it will keep fading. Similarly, like I said before, absorption spectrum is you are letting your light pass through a medium and then absorbing it. For example, you have a white light, you keep a green colored transparent paper, and then you look at the light. When you look at the light, what do you see? You see only green color, and all the other colors you don't see, because all the other colors are absorbed and only green color is what comes out, and that is what you call it as an absorption. Even in the case of an absorption spectrum, we have line spectra, band spectra, and continuous spectrum. So we call them as continuous absorption spectrum, line absorption spectrum, and band absorption spectrum. And the next very important topic is the spectrum from sun, or you call that as Fraunhofer lines. So when you have a sunlight, when the spectrum obtained from the sunlight is examined, it consists of large number of dark lines. That is, it is an absorption spectrum. It is a line absorption spectrum. This dark line in the solar spectrum are known as Fraunhofer lines. What do they tell us? What does this dark line tell us? The absorption spectra for various material are compared with the Fraunhofer lines in the solar spectrum, which helps in identifying the elements present in the sun's atmosphere. So, some elements that are found with the help of this Fraunhofer lines are hydrogen, helium, sodium, and so on. When continuous spectrum is emitted from the central hot region of the sun, that has to pass through the outer cold region of the sun. I think you'll be able to imagine your sun is a sphere. The center of the sun is very hot when compared to the outer layer of the sun. So when it travels from the inner portion to outer portion, the hot gas inside the or the hot portion of the sun gives out the radiation which passes through the cold region. That cold region will absorb certain radiation, and only then we get the spectrum here. So these elements are the reasons behind the absorption. So the solar spectrum or Fraunhofer lines helps us to find the elements that are found in the sun. So children, so far we have learnt about what is an electromagnetic spectrum, the sources, the application of each members in the family of electromagnetic spectrum. We saw what is blackbody radiation, temperature and radiation. And then we learned about emission spectrum and absorption spectrum. And at the end, we discussed about Fraunhofer lines or solar spectrum. So with this, it's only the mathematical portion left out, and we will be discussing about this mathematical part in the next video. Till then, listen and answer the questions. Don't forget to take notes. Thank you.